All right, 3, 2, 1.
Good afternoon, everyone. How's everybody doing? I hope you guys are having a good Friday. Appreciate you coming and spending some time with us. As we get started, I'm going to have Justin paste a link in the chat where you can go over and answer this question so that I can kind of get a feel for who's in my audience today. And I'll go through some intro stuff, and then we'll come back to this and kind of see what our responses look like. So this is me. I started tinkering with technology in high school, where I wrote my first program in BASIC on a TRS-80. Yes, I am that old. The following year, my father gave me an IBM PC-AT, which I subsequently tore apart and rebuilt. I paid for a good chunk of my college education working for a small educational software company. And then after a few years hiatus from technology, traveling and living overseas, I went back to work for that same company in 2001. I ended up building and managing their QA program. That's also where I got my start in test automation. And now 20 years later, here I am, a principal consultant with Improving. And I've been with them about 3.5 years. My primary engagements tend to focus around technical coaching in the area of quality and test automation. All right, so let's go back to our survey and see how we're doing here. I got 3 responses. I know we have more people than that in the audience, so if you got a chance, you can come over here and just kind of tell me who you are. That'll help me know what we look at. So we've got a couple of developers, got a manual QA. We'll leave this up and running for a little bit, give people a chance to check it out. What I want to do is to start by telling you some stories. These are stories from my personal experience. They are about real people in real companies solving real problems. I have obviously changed the names to protect the innocent. In some cases, I've created a composite story to help illustrate a point, but nothing here is really fabricated. These are really real experiences that I've experienced over the last few years. And we're going to start with James. This is James's story. James was an automation engineer who had the opportunity to go work for a small company, very much like a startup, but they'd been around a few years, long enough that they had some, legacy code bases. The company hired James because they didn't have any QA, and while they had done a pretty good job with quality, there were some cracks kind of starting to show, and they wanted somebody to come in and help build a quality program to make sure that they continue to provide valuable and high quality products to the marketplace. His role was to be more than just an automation engineer, even though that had been his primary function in his previous previous jobs. But they really wanted him to design a quality strategy and a process for the company. So James spent the first few weeks, couple of months, kind of taking stock of things, learning about the software and the environments, learning about the teams. The challenge for James, though, was that he was the only person in the organization that had quality in his title. And the company really had no plans to hire additional talent to fill that role. So James set about designing a quality strategy that focused on driving quality without a team of quality analysts. And James's strategy was basically twofold. First thing, he said every story, every work that we do, every defect has to have automated checking to cover the acceptance criteria. Now, those could be unit tests, that could be API tests, that could be customer-facing end-to-end tests, but the team had to decide what types of tests were needed, and priority was given to tests that could run fast, like things that could run sooner in the delivery pipeline, like unit tests or integration tests that could run in memory without having to be deployed into an entire environment. The developer who was writing the code had to also write the automation. The second thing was peer review was required for all stories and their accompanying tests. So someone else on the team, another developer, had to review the code, had to run the tests that they had written, evaluate those tests against the acceptance criteria, do some additional manual testing on the story, and that was essentially how they tested their stuff. So James, on the other hand, spent most of his time not writing automated testing, but he was trying to find ways to empower the developers on the team to write better tests for themselves. So he did some lunch and learns to talk about test-driven development, architecture testing for testability, exploratory testing techniques and heuristics. And he also spent a lot of time learning about and implementing CI and CD pipelines using tools like TeamCity and Octopus Deploy to enable the teams to have fast feedback and to be able to deploy quickly into test environments and ultimately into production. So fast forward about 4 years, and the two Scrum teams were at, when they started, they were delivering about once a quarter into production, and after about 4 years, they were on average deploying about twice a week. They had somewhere around 1,800 unit tests that ran in about 90 seconds, 9,300 integration tests that took about an hour and 40 minutes to run, and around 1,750 customer-facing end-to-end tests, which, by the way, is about 1,500 too many, but that's a discussion for another day. But the coup de grace really of what these teams built was a test generator that dynamically created and ran around 31,000 integration tests in about an hour. Now, to understand the significance of this, I need to explain a little bit about the product that was being tested. The product was a data analysis engine. The company ingested terabytes of data from their clients and then provided a dynamic query engine on top of that data store to allow the clients to kind of slice and dice the data and look at it in any number of ways over a rolling 2-year time frame. And so what that meant was the combinatorial factor of the potential data inputs that could be chosen by any given customer was astronomical. And what they were discovering over time was that most of the defects that found their way into production were some combination of query parameters that they just didn't think to test because there were just so many. So the team collaborated with James, and they came up with a solution to use the query engine metadata. This is the production metadata that describes all of the possible inputs a user could choose to automatically generate queries and to execute those queries. And so initially there were about 5,400 of these queries that were being built, and they ran those to the query engine, made sure they compiled and were valid queries. In the first pass of this, those tests took about 5 hours and 30 minutes to run. And what they were discovering through this process is that the tests often failed to complete because of timeouts. And that was actually pointing to performance issues with the query engine itself. And so they iterated on that. They fixed some of those performance issues. They extended the test suite to eventually cover about 31,000 different permutations in tests. And those got it down to where those tests ran in about an hour. And at the end of the day, that was the end of production defects because of bad queries. And in fact, all of these things combined, the unit testing, the integration testing, the peer review, the query generator, and the testing engine, allowed the team to achieve 4 nines uptime. I think they had maybe about 2 outages in 2 years and almost no production defects. Most of the production defects from that point on were really usually missed requirements or a failure to really understand what the goal was. So clearly a very successful story with an organization that didn't have anybody with QA in their title except for James. So now I want to tell you Suris' story. Suri was a veteran quality professional, but she'd really never done much automation. The company she worked for was moving very quickly down the path of DevOps and continuous delivery. She was struggling, though, because of her lack of experience with automation technology and the growing need for her to test faster the work that the team was producing. And she recognizes that she needed to get her test cases automated, but she really had a steep learning curve on top of just having to keep up with all the work that the 5 developers on her team were producing. She did some research. She came across a test automation tool that was low code. It seemed to provide a pretty low barrier to entry in terms of having to know how to code to get started. So she set up the tool and started working on building some test cases with it. And she made some progress, but was still falling behind and really felt like she didn't have enough bandwidth to adequately test the new features and get her regression tests automated. This is not an actual picture of Suri, but I'm pretty sure I saw Suri make that exact same face at one point. She was bumping up against some of the barriers with the tool that she had selected because the out-of-the-box capabilities were just not sufficient for some of those cases that she had. And she did enough research to know that what she wanted to do could be done with the tool, but not without some custom coding. And she just couldn't figure out how to write the code. She just didn't have the experience or the knowledge. And even just understanding what the community posts were saying sometimes was a challenge because they were using developer language that she just didn't really know. And so out of desperation, one day, she reached out to a colleague on another team, a developer who had kind of supported her and helped her get this tool set up. And he asked him for help. And he listened to her problem, and a number of common development patterns started coming into his mind. And he said to her, you know, what you really need are some data builders using this existing API that we have to help set up the data for your tests, because then you can eliminate like 60% of these test steps and just focus on what's really important to this test. Give me a couple of days, I'll go build those for you and set them up as keywords in the test tool, and you can just use them. And that's what he did. So this experience led Suri to the thought of, what if I ask the developers on my team to collaborate with me on each story to see how we can more efficiently automate those test cases? And she brought that up in retro, and they agreed to do some experimentation around that. And one thing that Suri learned really quickly was that a lot of what she was trying to write automation for at the customer-facing end-to-end level had adequate code coverage already with the unit tests the developers were already writing. And she just didn't know that because they never talked about it. She had no visibility into the testing that they were doing. And this led the team to adopt a practice of talking about test automation as part of their backlog refinement and planning how and at what layers of the code base they could most efficiently and adequately test the acceptance criteria. And because developers could write those tests really fast, they ended up just taking ownership of 99% of the automation, and they were able to refactor those early tests that Suri had written, applying patterns like page object model that reduced some of the maintenance issues that she was struggling with. Also, since they were the ones making changes to the code that broke the automation, it was a lot easier and faster for them to just update the automation when they were making code changes, rather than waiting until some later time. And the cool thing for Suri is that she was able to take on a new role, kind of a growth opportunity for her, and she really kind of became the quality coach for the team, informing the team as to what should be tested and how, and that really gave her more time to focus on high quality manual exploratory testing, which is where she was really strong. I was going to tell you a story about Tom and Jerry, but not that Tom and Jerry, sorry. Yeah, this is a better representation of Tom and Jerry. And by the way, I'm going to stop right here and just say, if you guys have questions, please put them in the chat. Justin, who's my co-host today, is watching for those, and he'll collect those, and I'll have opportunity to respond to those questions a little bit later. So Tom and Jerry's story. So Tom, he was a test automation engineer that had a lot of DevOps experience, and Jerry was a developer who had in recent years shifted his focus to become a quality engineer. And they were paired together on a team building an e-commerce site from the ground up. This team had really gifted developers, an excellent UX designer, and a really good working relationship with the client. It was kind of the perfect collection of circumstances for a Scrum team. And the team had a working agreement around the testing, which was that all stories would have unit tests that were written by the developers. And then Tom and Jerry would manually test each story as it was completed. And then they would tag team automating acceptance tests during the downtime. So this worked fine for a few months. but then a number of defects started getting through to production. Actually, the number of defects getting through to production, both in quantity and severity, began to increase. And as the team kind of retrospected on what was going on, it turned out that Tom was actually spending most of his time building and tweaking the CI/CD pipeline using his DevOps experience, and Jeremy was got focused on building some data builders and utilities to help make automation testing easier. But neither of them was really spending near enough time actually testing the new features that were being built. They had kind of got tunnel vision on things. They were distracted from their actual task of testing. And they were just failing at the fundamentals of testing, even though they were doing automation. And eventually the client got fed up with the poor quality and cut the team loose and replaced them with another team. And so you may have thought this story was going a different direction based on the first two, but it holds an important counterbalance to my main thesis that I want to make sure I bring out and come back to in a bit. So the question is, what is my main thesis? And that is, I believe teams will be most successful when automated checking at all levels, unit test, component test, API, UI, whatever, is primarily owned and maintained by developers and not quality analysts or offshore teams, which is the pattern that I often see. But this must be done while maintaining a high degree of collaboration with QA. And so I want to kind of highlight some key reasons why I think this is true. First of which is that automation is fundamentally programming. Even the low code and so-called codeless tools are producing code in the background. And how good that code is will be a direct reflection of how well you understand coding constructs and how what you're doing through the tool's UI affects the kind of code being produced. And you will always need to extend those tools. Like off-the-shelf tools, by their very nature, tend towards the lowest common denominator. And when your requirements step outside the standard path, then you need to be able to write code to extend the tool's capabilities. Okay, so I'm going to stop for a second. I want to do a little experiment. It's not something I've done before, so I'm not sure how it's going to work. So let's see, we got 21 responses now. Let's see how we line up. So we got 10 developers, we got 3 manual quality analysts and 1 test automation engineer, a couple of scrum masters, a couple of managers, directors, C-levels. So if anybody else hasn't put in their response, I'll give you a few more seconds here. All right. Distribution is not exactly what I was hoping, so this may not be as enlightening as I hoped it would be. But we'll try it anyway. So it's an experiment, right? So find your little emoji icon in your Teams interface. And what I'm going to do is I'm going to put a question up here. And I just want the QA people. So we got about 5 or 6 QA people. If you're an automation engineer or manual QA, doesn't matter. But no developers, no Scrum Masters, POs, or whatever. Just the QA people to respond to this question. And so read the question and then we'll work through the different responses and I'll have you give me an emoji for the response that you think most represents your level of understanding. So I am familiar with the concepts of encapsulation, inheritance, and composition and could easily explain them and use them to build my automation framework. So if you have never heard of those things, give me a thumbs up or a hand clap emoji. Okay, that's good. Let's see, I have heard of them and might be able to define some of them, but don't ask me to explain in detail or use them. All right, thumbs up, emoji. Oh, okay. So this is going to be a total flop of an experiment. That's fine. I can explain them, but not sure I would know how to put them in practice when writing an automation framework. Thumbs up. So am I just not seeing the responses? Is that the problem?
Yeah, I'm not sure that the live event interface has those responses. I can't see what they're seeing on their end, but yeah, that's what I'm getting in.
Okay, well, that was a failure of an experiment. but that's why we experiment. So we learn. Okay, let's just go on then. So what I was expecting is that for the QA audience, most of them would be 1, 2, or 3 on this bullet point. And then I was going to ask the same question of the developers, and I would expect them the distribution to be primarily 3 and 4, just to illustrate that developers understand these concepts as where a lot of people with a QA background, particularly those that don't have automation experience, probably are not familiar with these programming concepts. And here are some other things that you would need to know as an automation engineer. Decorator pattern. We use this a lot for injecting logging or for test case management to build test suites. The facade pattern is used a lot of times to encapsulate complexity and provide a simple interface for your test layer. Factory method. And for QA engineers out there, this is not the page object factory, which is a common pattern, although it itself is an example of a factory pattern. But this is the primary pattern that we use with Selenium WebDriver for initializing the core WebDriver instance. The builder and object mother patterns, a couple of my favorite patterns that can be used to greatly reduce the number of lines of code required to set up a specific data state required for the tests. Singleton and strategy patterns are a couple others that are commonly used. The query engine that James built, or that James worked with the developers to build in his story, was fundamentally the application of the strategy pattern to take metadata about a query and hand it to an execution strategy. And I've linked to an article in the bottom of these slides here that's a good summary of these different patterns and how they apply specifically to test automation frameworks and testing. So if you want to do a deep dive on that topic, that's a good place to start. But my key point here is that test automation is code, and that all of the patterns, all of the solid principles, all of the design patterns that apply to good code apply to test automation. So the second reason I think developers should own automation is that it drives testability. And I'm a big proponent of test-driven development, not just because it means that you end up with a bunch of unit tests, but primarily because of how test-driven development, when it's done well, drives usable public-facing APIs, decouples code, forces single responsibility, and a whole host of other desirable characteristics of quality and maintainable code. And the same thing happens when a developer is engaged in writing test automation for APIs or for their front-end UI. You take a front-end test, and a developer is going to spend about 30 seconds flat trying to figure out an ugly XPath to reference a element that's buried in some nasty DOM on an HTML page before he's just like, forget that. I'm going to go add an ID or a data attribute to that element so that I can easily identify it in the test tool. And you contrast that with the standard pattern that I see where an automation engineer is automating code that was merged to the branch last iteration, and now they're coming across that ugly DOM code, and the developer has long moved on to another story. And so at this point, the automation engineer's choices are to, spend a lot of time trying to figure out a stable selector, or throw some big long 73-character XPath at it, which he knows is going to be unstable, but does he have another choice? Or maybe he can kick it back to the developer and hope the developer can slip an ID or a data attribute in while working on the current story and get that fixed. Or a worse pattern is you write a deep. Yeah, sure.
Says, do these patterns tend to apply across both UI and API testing, differences notwithstanding?
Yeah, so they are patterns that will be used at all different layers of automation. The three that I highlighted initially, composition, encapsulation, and inheritance, I use those all the time in building UI-facing test frameworks. Some of the other ones would be more applicable at lower levels of testing, but yeah, they would certainly apply. Some of them would certainly apply at the UI level. Does that answer your question?
Yeah, I think that's good.
Okay, so if a developer is doing automation, they're going to make the code more testable. It's going to drive that testability of the code, because they're going to start thinking about testability. They're going to start injecting testability to make things easier to test. And the third reason why I think developers should own automation is that it provides the fastest available feedback loop. So automation is all about how fast we can learn how our recent changes have affected the system. And the shorter that feedback loop is, the more efficient and cost-effective our development becomes. So developers are the ones making changes to the code, and they're likely the ones to break the automated tests in the first place. So if an automated test fails and turns the pipeline red, there's three primary reasons for that. One is there's a flaky test. You have a false failure. Maybe it's a page didn't load quite fast enough. Maybe the data was dirty and not in the state the test expected it to be in when it started. And if you just rerun it, it will probably pass. This is a symptom of a poorly written test or an unstable environment. And a lot of times the application of one or more of those design patterns or other programming principles can bring stability to that flaky test so that you can start to trust it. But you often need a developer's expertise to kind of tease out how to make that more stable. It could actually be that the test was broken by changes that the developer made. It's not a bug, it's just, hey, we changed this ID on this element and now the element locator is broken. And so we have to go fix the test to account for that change. But who changed the code? And who is in a position to discover and fix the broken test the soonest? And consequently, be able to fix it the fastest and the cheapest. How much time would it save you as a team if developers found those issues before opening a pull request, merging the code, having it deployed into an environment so that the QA engineer could come along and discover it, a few hours or a few days or maybe even weeks later? Or that test could represent a broken piece of functionality that the test is uncovering and catching. And again, you would want your developers to discover that before merging and pushing code out. And so if they are owning the automation and they're able to run the automation locally, and your automation is fast and efficient, then you're going to get the best of all of these things as developers take on that ownership and become the primary maintainers of that automation. Okay, so automation is code, and all of the things that apply to good automation apply to test automation, or to apply to good code, apply to good test automation. Having developers own automation drives testability and also provides for the fastest feedback loop. Okay, so I'm going to stop right here and see if there's any other questions.
Don't have anything else right now.
Okay, cool. So I want to spend the rest of my time just presenting a model for collaboration between QA and dev to facilitate successful test automation without falling into the pitfall that Tom and Jerry found themselves in. And I want to do that by way of Allen's laws of successful automation. So if you're a fan of NCIS, Gibbs has his rules and his head slap, which is also a favorite of mine. If you are a fan of Gerald Weinberg, you've probably come across his laws of consulting or his general systems thinking laws. And I think it's an effective way to remember stuff. So here are my laws for successful test automation. Law number one, and I've named this James's law after James's experience. When it comes to test automation, QA should inform automation and developers should enable automation. So you want to leverage the skills and strengths of the people on the team to shine in the things that they are good at. QA should be collaborating with developers about what should be tested, what kinds of inputs, what kinds of scenarios, what kinds of boundary conditions. Developers should be applying their skill to figuring out the most efficient way to automate those tests and at what layer of the testing pyramid is most effective. And so this is a shift for those quality people to become coaches to impart to developers a testing mindset and help them to become more customer-centric in the way they think about how testing works and how software works. Now, if you're an automation engineer, you might be feeling like there's no place for you in this model, but the answer is you absolutely have a role to play. And if you are an automation engineer, you've got a lot of experience, you understand the programming things we learned earlier, or maybe you're starting to gain a better understanding of those things. Here's a chance for you to pair with developers and get even better. If your primary role is automation, then keep doing that, but make sure you are doing it in collaboration with developers. Make sure you are automating against what you're working on, what they are working on now, and not waiting until the next sprint or doing it out of band. And that's going to come into the next law that we're going to talk about. But pair with your developers, learn from them better ways to achieve your goals, provide feedback to the developers on what will make life easier for automation, and you can drive that testability and that discussion around what makes things better for the testing tool. So you are in a special place to be able to bridge that gap between QA and dev. Okay, rule number 2, this is Suris Law. The definition of done for every story and defect must include all automated checking at the most efficient layer of the test pyramid possible. So that means that before developers go off and start writing code, they need to spend time collaborating with QA to define what examples are we going to use to validate the business rules encapsulated by the story, or what tests need to be written to reproduce the defect that was just reported by a customer in production. If you haven't read Specification by Example by Gojko Adzik, I highly recommend that book as a way to kind of do a deep dive into what this process looks like. But using concrete examples as you're testing and defining those before you write the code can really help flesh out the key scenarios, examples, boundary conditions, equivalence partitioning, and things like that, that will make programming a lot easier and will make testing a lot easier. And the less time the more time you spend discovering those things early on before you write the code, the less time you do that after the fact, after a lot of code has been laid down. If you're an automation engineer and you've been able to do that collaboration up front, now you can actually go start stubbing out those tests. You can go build or modify your page models so that you are ready to integrate working tests as soon as the developer has finished his working code. You guys can even work in the same branch so that your code can be deployed together and can run together.
Got another question.
And law number
for you.
3. Okay, sure.
Says, why do organizations opt to not automate at all? I find this hard to wrap my mind around and would like to better understand why they take this stance so I can work on a better way to address this topic.
So that's an interesting question because I've never come across an organization, at least in my experience, that didn't want to automate. Well, I take that back. I have had one experience where they had tried automation and failed. And because of that experience, they were reluctant to invest any more capital in test automation because honestly, test automation is expensive, particularly if it's not done well. And so I suspect I would want to know the history of that particular organization, and you might find that there was some failure in the past that has led them to a decision that that automation is not worth the cost. And if that's the case, then a discussion around what caused those scenarios to failure. And by the way, 70% of automation initiatives fail in the first year. So it's not an uncommon thing because we throw people into automation that don't have the skills in the background. And there's a lot of tools out there that can enable people without that background to write testing. But the problem becomes maintenance. And if you don't understand some of the principles that I've touched on today, you can end up very quickly with a test suite that is going to collapse under the weight of its own maintenance pretty quickly. And so I'd want to understand what that organization's motivations are for not wanting automation. And then I would also look at books like Accelerate, which is, and I'm going to actually talk about that book in a little bit. I'm going to pull out some key point from the book. But Accelerate is a scientific evaluation of over 300 companies across multiple organization sizes, multiple industry verticals, where they looked at high-performing teams in high-performing organizations and the practices that allowed those teams to be exceptional and high-performing. And what they've discovered is that automation is a fundamental part of high-performing teams. And so that's a book that you can go to look at the actual industry data to say, if you want to be competitive in today's market, this is something we have to learn how to do as an organization. And I would probably begin to approach it from that perspective. But understand the history first, because the history is going to inform the questions that you need to ask and answer to get organizations to start thinking seriously about automation if they're reluctant to do that. Any other questions?
You just had one more come in. At what size of a project do you recommend shifting to automation testing beyond unit and integration tests?
Ideally, from day one. If you're writing acceptance criteria and you have a full vertical slice of a piece of functionality, you should be writing automation around that. Now, you still need to ask the question, what's the appropriate layer of the test pyramid to write automation? But that could be at any layer for every story. And so I would want to start in a greenfield. Tom and Jerry were writing a greenfield project, and the only thing they failed to do is to keep a focus on, well, they failed in a couple of ways, but the manual testing piece of it is where they failed, and they didn't do a great job at the automation, but that was for different reasons. But they were in a great opportunity to do that in a greenfield. I've worked with other teams on greenfield where they automated from day one. And for legacy products, you have two challenges. One is you're continuing to change to that product and grow it, and you want to be sure you're adding automation around all of that new work. But then you probably also have a legacy suite of manual test cases that you've collected over the years. And the challenge that you have is how do we get some of that stuff automated as well? And I have worked successfully with a recent client to kind of build that into our team's capacity as tech debt. And we went through those test cases, those manual test cases in collaboration with developers, deconstructing those into the test pyramid, simplifying those test cases, and then just allocating a developer time to getting that stuff automated, or test automation engineers time to getting that automated as part of every sprint or every release cycle. So it's never too early, I guess, is the short answer, to start automating even at the UI level. If you have a vertical slice of functionality, you have the opportunity to do automation at all the layers. And the sooner you start, the better off you're going to be. All right. So let's talk about Tom and Jerry's Law, and then we'll have time for more questions here in a little bit. So Tom and Jerry's Law is, while focusing on building high quality automation, never neglect to actually test the application. And just don't lose focus on the goal. I mean, the goal is quality, and automation cannot replace manual testing. It can facilitate time to do better manual testing. You need to be automating anything that the manual tester is doing that is repetitive, that is time costly, that can be automated. But automation doesn't discover new defects. Automation protects you against regressions. If you're building new code, you doing highly skilled exploratory testing is the best way to find those defects. And the best way to make space for that kind of testing on a fast-moving Scrum team is to offload that automation to those who do it best, so your quality professionals can focus on what they do best. And that's actually a corollary to Suris Law, which is one of the things that made Suri very, very successful, was she offloaded that technical automation stuff to the people that did it well, so that she could focus on that manual exploratory testing that she did really well. So anecdotal evidence is great, and I've given you some stories of my own personal experience, but I am an evidence-based metrics guy. I like to know what does the data actually tell me. And so the book Accelerate, The Science of Lean Software and DevOps, is a scientific evaluation of 355 companies, and here's kind of firmographic from the 2017 data that they used in their research to show you the companies that are represented, which size companies, which verticals they represented, the amount of technology that they had, number of employees. And these findings that they came across were none of these things really were critical to, what vertical you were in or the size of your company was critical to the question of whether you were a high performing or a low, medium or a low performing organization. What they came across was 24 characteristics of high performing teams, and kind of where you fell out in that medium, low to high really was reflected by how well you were implementing those 24 different characteristics across technical, cultural, and organizational categories. And one of the things that they discovered in their research is that high-performing teams, often it was developers who were primarily creating and maintaining acceptance tests, and that they can easily reproduce and fix them on their development workstations. It's interesting to note that having automated tests primarily created and maintained either by QA or an outsourced party was not correlated with IT performance. And the theory behind this is twofold, right? The first is that when developers are involved in creating and maintaining acceptance tests, first, the code's going to become more testable, like we talked about that. And second is that it forces developers to create more testable designs in their code, which just drives code quality all around. And then the second reason is that when developers are responsible for the automated tests, they're going to care about them more, and they're going to invest more effort into maintaining them and fixing them. And so this data really backs up and provides support to what my own personal experience has been, in that if you will leverage the experience of developers and get them to take the primary ownership of test automation, but in collaboration with QA, so that QA can lend their expertise from a quality perspective to inform that automation, that's going to really drive quality, and it's going to drive efficiency in your test automation, which is going to drive efficiency in your overall development lifecycle. So again, devs should own all automation in collaboration with QA. That's my primary thesis. So I'm going to stop now and see if there are any additional questions, comments, criticisms, or rude remarks that you might want to make. And then we'll wrap up from here.
I've got one more question, kind of adding to the previous one about what size do you need to start adding automation. He says, what about like team size or project size based off of like budgets? Because, a 20K budget is much different than a 500K project, that kind of thing. And how does like automation fit into both budgets?
So I think at the end of the day, the question you want to be asking is, when we get to the end of our budget, what do we want to have? Do we want to have quality software? Or do we want to have something that might work, but is going to be hard to maintain and grow as we go forward? And I suspect somewhere in here is a discussion about, well, we want to do an experiment, we want to do a spike, we want to get something out and see how the market responds to it. And that's a very valid way to approach a new software development project. But you need to understand that if you don't build it with quality and the market says, wow, this is awesome, we want more of this, now you're in a bad situation, because you have to start delivering and moving faster, but you've built yourself into a corner of poor code. And so how do you recover from that? And so I don't think any of the things that I've talked about really matter what your budget is. It's about building quality software. And if you don't build quality software, you're going to fail to be competitive in the long run. So I think that's how I would approach that question. And so when you're budgeting, you understand that part of that budget is quality. Okay, anything else? Or do you want to elaborate on that question? All right, cool. So let me jump back to here for a second. So again, here's my contact information. You're more than welcome to reach out to me on LinkedIn or send me an email. Just give me some context. If you reach out to me on LinkedIn in particular, just give me some context for where you learned about me, so that I can, I'm less likely to just reject your request to link up if I know where you're from. And if you have questions, you want to have an extended conversation about anything that I've talked about, then please feel free to reach out to me. And I would enjoy talking with you.
One more last minute question if you got time.
Oh, perfect. Yeah, perfect.
Seems like nowadays most recruiters, managers, etc. want automation engineers. From my experience, manual testing can be seen as the redheaded stepchild. As a tester, how can we educate others the value of manual testing?
Yeah, this is a real problem, and it's a challenge, which is why I try to, almost every time that I give a talk, I try to talk about the value of manual testing, because if you just do automation, you're going to fail in quality. That's Tom and Jerry's experience, right? And we just have to continue the discussion. We have to continue to talk about the place that manual testing plays in automation, or sorry, in quality, the value that it brings, talking about what automated testing does and does not do. I've already kind of said it in passing that test automation is like clearing a path through a minefield, and it ensures that nobody comes along behind you and reintroduces a mine along that explicit path. But it doesn't tell you whether there's a defect to the right or to the left of that path. And you can have automation that does 100 paths through a minefield, but there's still going to be holes. There's still going to be defects that are complex. There's going to be things like visual defects, usability issues that automation is just not very good at capturing. And you need manual testing for those specific types of things. So you have to continue that discussion, both within your organizations and, when recruiters are putting together job descriptions. I think it's important to look into those descriptions and see, is this 100% automation, or is there going to be any manual testing going on here? And to pull that out of those job descriptions. But yes, you have to educate and continue to have the discussion about what automation does and what manual testing does. I like the 4 quadrants of agile testing from Lisa Crispin and Janet Gregory in their book Agile Testing. I go back to that a lot, and in those quadrants 1 and 2 are mostly about automation, but quadrants 3 and 4. Now 4 to some degree is automation and technology, because you're talking about performance testing and security testing. But quadrant 3 is firmly in the manual testing space, and it's an important quadrant. You can't do the 4 quadrants of agile testing without quadrant 3. So we just have to have the discussion and continue to raise the visibility and value of manual testing. So great question. Thank you for bringing that up.
Yeah, one more. Can you talk more about the quality coach role? How many Scrum teams to support? What responsibilities does it have, and that kind of thing?
So I think the quality coach, I think a person can support multiple teams if the teams are adopting some of the practices that I've talked about today. But again, I still feel like the quality, each team should have a quality person on it, and I think that person should be the coach for that team. And the reason for that is that you need to be involved in your backlog refinement sessions where you are talking about each individual story so that you can collaborate with your developers at that point in time. You need to be involved in being able to do the manual exploratory testing side of things. And it just works better if there is that coach on each team. That doesn't mean that a coach who is really good and a team that has matured in these practices can't share that person's ability and skills across multiple teams. But I really feel like it's better if that person can focus on a given team. Even as a client, even as a consultant, when I come into a client, it's a challenge for me, even with the years of experience that I have, to split my time between multiple teams. And I generally talk to my clients about, hey, can I focus on this team? And then once that team gains some maturity, then I can shift my focus on another team. And so maybe that's an approach you would take within an organization where you have a quality person that wants to kind of move into this role, is they can pioneer it with one team and show success and get maturity on that team. And then they can switch places with a quality person on another team so that they can share that with another team. So it just kind of depends on the team and its maturity, but those are some things that I would think about for that particular role. Good question.
Well, that's all the questions I have.
All right, great. Well, we're right down to about 4 minutes left in the hour. So thank you again for spending your lunchtime with me. I know you guys are busy, and I really appreciate that you would give up time to come and hear what I have to say. And hopefully I've given you some things to think about and some things that will be valuable. So thank you and have a good day.